Hi everyone, and welcome to today's installment of the Build Your Simulation Moldflow IQ. Today we have Kristen Kilroy speaking to you about identifying mesh and geometry issues with Moldflow. The slide deck from today will be available for download, and we will discuss where you can find that as well as the YouTube recording of this webinar in the following slides. Throughout the presentation, please feel free to ask questions along the way. This can be done using the WebEx panel you see on the right of your screen. We have Kristen, myself, Paul, Javier, and Jay here to answer any of the questions you may have along the way or at the end of the webinar. Some of the past webinars we have done are understanding Moldflow Insight automatic reporting tools, as well as match the simulation to reality. Some of the upcoming topics we will be having webinars on are the cooling methods in Moldflow Insight, which will be broken up into a two-part series. Also, understanding warpage and shrinkage in Moldflow Insight. Again, this recording will be uploaded to our YouTube channel, which is Autodesk Sim 360, and we have a list there which contains the entire webinar series for all the simulation products. Lastly, shown in the bottom right of this slide is your options for signing up for future webinars. You can use the forums, autodesk.com/help-webinars, SimHub, and also through direct email. One last thing we like to point out before really diving into the information of this webinar is that we, as technical support specialists, also create Moldflow support knowledge articles. If you go to knowledge.autodesk.com, these articles we create can be accessed to help you as the users troubleshoot many of the issues or questions that you may have. Listed here are some of the recently published articles for your reference. Also shown on the slide are the current service packs available for download for Moldflow Advisor and Insight 2017. It's always a good idea to install these service packs when they become available. You can find direct links for download of these service packs by going to the knowledge.autodesk.com/download. I'm now going to pass you over to Kristen, and she will start you off with an overview of what we will be discussing today.
Thanks, Beth. As Beth had mentioned at the beginning, today we're going to talk about basically mesh and geometry issues within Moldflow. So this will be anything from you getting error messages, and we'll go through a couple instances of that, and then lead into a brief overview of CAD geometry imports, meshing, and then how to actually troubleshoot those issues within Moldflow. And what we'll do with the rest of the time is go through a demo. I have a sample part there for us. And again, as Beth had mentioned, I did upload a PDF version of this slide deck that you can follow along with on our Box website. So you can go there or either before or after we start going into these. And then I also uploaded the demo models for you to take a look at as well. All right. So say you're running an analysis and you get a analysis failed error. Uh-oh, what do you do from there? So best case scenario, you're getting a error message or a warning message that says basically it's related to the mesh. Again, error messages would pop up with that analysis failed. Warning messages might just show up here and there. Not necessarily stop the analysis from running, but it will bring it to your attention in that log file. Now, sometimes you might see a couple warning messages and an error message, so use those to help to take a look at what could be wrong in that error, or in the analysis failed there. But worst case scenario, I know everyone's come up with it one time or another. The analysis failed and there's nothing in the log file. You're trying to figure out what's wrong with your analysis and you don't really know where to start. You can also get an error message that basically doesn't give any inkling that it's related to the mesh. Now, this is what we're going to be talking about today, kind of taking that approach Whenever we see cases come in for analysis failing with support cases, we typically first go to the mesh. That's our first instinct, to go look at the mesh for issues. Now, taking a step backward, I wanted to go through a brief overview of Moldflow and how it's really importing parts into it, as well as the supported model types and advice on the initial import of it. So this is just a chart I pulled from the Moldflow help files, listed the link there. And basically it's showing that Moldflow can import a lot of different models. If you're using a pre-2014 release, then you might need the design leak option, and that's licensed separately. But for newer versions, that's all included. So for importing any of these model types, it'll just automatically import into Moldflow. Now, one thing that I'm sure most of you have heard one time or another is we do strongly recommend using native CAD files, because whenever you import a model through Moldflow, it goes through a translation into the program. Now, if you think of it, when you're exporting your model from your CAD program into one of these different file types, it goes through another translation to get it into that format. And then when you're bringing it into Moldflow, it's going through another translation. So introducing those several translations can cause different CAD things to go on whenever you're ultimately meshing the part. Now, looking at the CAD bodies themselves, one thing that we'd like to bring up is that with Synergy, you can import assembly files. That makes it easier for inserts if you're using a part insert or a mold insert, cavities of your mold, things like that you really want to take into account with thermal history within Moldflow, and then also runner system, feed systems, whatever, just getting a better representation of that within the model. Now, the recommendation is really to be sure to actually look at that geometry once you import it, or even before you import it. Take away any village chamfers, text, small non-critical features that don't really affect flow. Now, if you are using or are importing a part that has small features, then you do want to take a look at them. If they're critical to your part, try to put it in there, or you can keep it in there. Just put a local mesh to it, a local mesh density. That way the mesh will actually be able to capture it correctly and be able to better represent the flow on that. Another thing to mention that I didn't list on here, but talking about the import process again, when you export a model from your CAD system, many CAD systems offer a tolerance whenever you're exporting. Keep an eye on that, because there could be some variations once you do import it into Moldflow that you don't really realize until after the fact, when you're taking a look at the dimensions of the part and so forth, that tolerance might throw things off a little bit whenever you mesh it within Moldflow's meshers. So that's a good thing to keep in mind once you do that export from your CAD system. And here you can see I just put an example of the text, so embossed text on a part. You can see here there's a lot of high aspect ratio elements. It might not necessarily call for warnings, or might be above the recommended range for these aspect ratios, but it's just something to keep in mind, again, when you're looking through that simplification process, to try to eliminate and simplify that as much as possible. Do we really need the that text on there, the sans on there, or can we do without this completely? Now, one thing I wanted everyone to think about is, where do you get your models from? Do you create the CAD geometry yourself and then import it into Moldflow yourself and do everything on your own? Or do you get it from a customer or a colleague or a designer who's really has control on that geometry? If you do, that's perfectly fine. You just want to be sure to keep in mind that whole importing into Moldflow. Is it simplified? Is the geometry okay to import into Moldflow? Is it a native CAD file? Are you working with the most recent version? And again, that's going to save you time in the long run. If you notice that you get through an analysis and all of a sudden you realize that, oh, it's a different geometry from what they're using at the actual tool being cut, then that could be a big problem in the end. So keep going back, checking that version number, checking to make sure all the features align with your tool or with the part design, and that'll really help you in the long run. All right, so now we're going to just push a little poll out to you, kind of related to the geometry. Give me one moment here, I'll send it off. Here we go. All right. So again, this is related to geometry import. Are you looking at the CAD geometry once you get the model? Are you modifying it beforehand, or are you just importing it and running with it? All right, so it looks like the majority of you are looking at the model. We love to see that. Still coming in a couple votes here. Few people say they don't look at the model at all. Give it another minute here. Okay. And I'll go ahead and close the poll. Share those results with everyone here. So you can see here, the majority, 67%, are definitely taking a look at that model and simplifying it, making sure they're working with it to be better imported into Moldflow and meshed into Moldflow. There are some that do look at it sometimes, but maybe most of the time they try to rely on their colleagues to look at it first. And then there's a few that don't look at it at all. Okay, good to know. And like I said, this is just for curiosity's sake, just wanted to see where everyone stands on that. Okay. And back to the presentation here. Okay, now talking about meshing the mold or model. Going into the mesh, I did the majority of this information for Synergy, so Moldflow Insight and Synergy kind of go hand in hand. Again, Synergy is the user interface, and that's really what meshes the model. Once you get into the analysis, that's where Insight comes in. It's the solvers behind it. And then I also did one slide a little bit later here just on advisors import, just to show you the comparison between the two. So one of the most important things with Moldflow is getting a good representation of the model, of the CAD geometry. And that leads into being able to take a look through the thickness of the part, making sure you're capturing that thickness correctly, as well as capturing the flow in that thickness correctly. So you can see here I just kind of put a slide on keeping in mind the number of layers that you're using. For midplane and dual domain, you actually have to go into the advanced options through the process settings to be able to set these, and you can see at the bottom of the screen there, basically says number of laminae across thickness, and it's defaulted to 12, which is typically good to use. Every once in a while, you might think, oh, you need a little bit more resolution, so you might want to increase that a little bit further. On the right-hand side of the screen there, you can see the 3D meshing option. And you can see there it says 20, which is something that I just had set in there. But the default is actually 10 layers. And again, this used to actually be 6 layers, but the development team got together and realized that they really like to see a little bit more detail through that flow, through that thickness. So they increased the default to 10 layers. And again, this can be adjusted depending on what type of analysis you're using, what your geometry looks like, and so forth. Again, it's to try and get detail through adding more layers through the thickness to get the calculations to go from node to node in thinner layers than the default there. And again, it's a good thing to keep in mind. The higher number of layers through your thickness, the more time it'll take to analyze. So you really have to keep that in mind when you're looking to add additional layers to it. I think the maximum is about 40 layers. Very, very rarely have I ever seen anyone go that deep into it. But again, every application is different. For instance, if you're running a glass-filled analysis or a warp analysis, you might want to increase it from the default setting to maybe a few additional layers on top of that.
And Kristen, looks like we have one sort of question or comment at this time. Basically, 20 layers in 3D would models, you'd get a pretty high element count at that point, maybe upwards of potentially 5 million elements. Do you think that's still kind of practical with solving, or most likely not?
That's a good question. It's really, you can do it. You can certainly take it up to 5 million elements. Again, it's basically taking the geometry into account. Do you really need that number of layers through the thickness there? What you might want to try is running with a few less layers, maybe do 10 layers at first. Take a look at the results. Are you seeing what you want to see in there? And then increase it from there. Take it up and slowly increase it. That's typically my workflow, not starting at the top or starting at kind of a set amount higher than the default layer there. But when you start low and start gradually increasing, you can start to see where it's not really adding to your analysis. To add those additional layers in there, you're really seeing what you want to with, say, I don't know, whatever number seems to even out the results there. So again, it's kind of doing different iterations, kind of trial and error at some points on there.
Great, thanks so much, Kristen.
Sure, no problem. Good question again. All right, and keeping on that 3D point there, talking about the internal mesh a little bit more here. Whenever you're meshing into 3D, there are two options for you to be able to do this. You can go straight into the 3D mesh, so basically import your CAD model as a 3D model, and then just click Mesh right away, and it'll add those internal layers right off the bat. But you can also stop at that surface mesh generation, and what that actually allows you to do is, when you do that, it will stop it to make it look like a dual domain part, so it'll be a shell of your part. And with that, you can actually take it into the mesh diagnostic tools and look and see mesh statistics and everything like that to see if the mesh is actually suitable for meshing to 3D, fix any issues that you might run into with that surface mesh. That way, when you go to mesh it again as 3D tetrahedral elements, it'll actually reduce the amount of, or the need for manipulating the 3D mesh after the fact. And the only reason we suggest that sometimes, or most of the time, is to, again, catch those issues before you mesh it to 3D, because 3D mesh can be a little tricky to work with sometimes. Say you're merging nodes or elements, or merging the elements together, and it might cause collapses in the internal mesh or something. So again, doing that kind of stops it and gives you a checkpoint before being able to move forward. Now, one thing to also keep in mind when you're going to 3D mesh and specifying that layer count, so in the last slide I think we had 20 layers on that. Even though you specify a layer count, that doesn't guarantee that it will get that amount of, or that number of layers through every little thickness of the part. If you can see the picture on the bottom left hand of the screen there, it's basically a cutout of the internal mesh of a 3D part. And you can see that there's 6 layers that go through the thickness there. Say you actually specified 10 or 12 layers instead, but you're only seeing 6 there. Now, that's perfectly fine, but if you do want more detail there and you want more layers, you might have to actually go in and try manipulating it by disabling the match mesh option there, as well as the use surface mesh optimization and use surface mesh matching. Basically what those do is constrain it to the surface mesh. So once you disable those, it'll actually allow it to be more free when Synergy looks at the mesh, be more free to add those additional layers in there. Again, it's not guaranteeing that you'll get those layers, but it will definitely be able to try to increase that opportunity to add those layers to it. Now again, that was with Synergy. Now if you're using the Advisor program, which is more geared towards designers who want to get it in and analyze the part while they're still designing that part, what you can do is, or what you notice is you can't really see the elements, as I was saying in the previous slide here. You'll see more of just a green part, so your CAD geometry imported into Advisor. Advisor actually meshes the part whenever you click to analyze the part. So whenever if you look at the status bar, you'll see a stage that's called processing. That's actually when Advisor is applying that mesh to it. So whenever it's going through and processing, it'll apply that mesh but still keep it kind of hidden from your view, which is perfectly fine. Again, it's not cluttering up the screen or anything, make it easier to actually see the CAD geometry. But sometimes you do want to do a visual inspection of it after the fact. Look at the results, look at the part itself. Does it look choppy or anything like that? If it does, you can actually increase the resolution of it. So basically decrease the element size that Advisor is putting onto it just by increasing the levels shown on the right-hand side of the screen there. And doing so also increases the analysis time as it would with Insight, but this gives you a little bit of control on the mesh in Advisor. Now, if you do have both Advisor and Insight, and you're a little curious about Advisor's mesh on there, what you can actually do is import the Advisor mesh, so the study file, into Insight, and that actually results in seeing the mesh that Advisor is applying to it. So it's a good troubleshooting tool. I know typically whenever we get Advisor cases that could be related to geometry into the support team, we usually take it into Insight just to, again, help us with the troubleshooting and take it from there. But again, there is that limit of actually having Insight instead of Advisor in there. All right, so moving on to Moldflow specific troubleshooting. Whenever you do get the analysis failed box, now what do? What's your first step? First thing that we typically suggest is do a visual inspection. Does anything look wrong in the study itself? Then we look deeper into the mesh itself, so the mesh statistics, diagnostic tools, and use CAD programs to better troubleshoot if it's something with the CAD geometry or the mesh or both. Now, one thing to kind of throw out there, if you do see a blank log after an analysis fails, Moldflow takes a little while to analyze the mesh prior to actually writing that log. So sometimes you might have to go back and remove unused properties within your model, or even in some cases export as a patchran file and then re-import it into Moldflow, because then you'll be able to really kind of reset the properties behind it. And what that'll do is clear out and reset the Synergy solver, or I'm sorry, the solvers behind it to be able to read those properties behind it. All right, so now that everyone might be asleep, hopefully not, I'm going to throw another poll out to you related to troubleshooting mesh. So give me one moment here to send it out. There we go. All right. So basically, whenever you're getting that model and meshing the part, whenever you go to a 3D mesh, since we're kind of gearing towards 3D mesh here, do you do anything to the mesh? Do you check the mesh while you're before you're analyzing, or do you wait till after the fact if you get any error messages to take a look at it? Or do you only go halfway? Do you only check the mesh at the end of the mesh if you're meshing to the surface mesh, then to 3D? Give it another minute here. Looks like the majority of the users here are checking the surface and the 3D mesh, which is great to hear. But we do have some people that are not checking and some that are just looking at the 3D mesh. Give it another minute here. Okay, it looks like the majority of people have voted here, so let me go ahead and close it. Thank you all for participating in that. Let me show you those results. All right, so you can see here, again, the majority of you are checking the mesh both before and after that 3D meshing, which is great practice. You know, you really want to try to catch those mesh issues before you mesh it from that surface mesh to the 3D mesh. But again, even when you're just checking the dual domain mesh, that's always good too. Now, for those of you who are not checking, hopefully this presentation or this webinar today will maybe keep it in the back of your mind. Maybe you should take a look at those if you are running into any issues with your parts. Let me switch it back to the webinar here.
Hi, Kristen. This may be a good time for a couple more questions that we have. So first, is there any recommendation about the ratio between the length of elements in the surface mesh, part thickness, and number of layers? Basically, the user is commenting that because in thin parts, it's hard to obtain a good quality in tetra elements without a very fine surface mesh.
You know, that's a great question there, Beth. Thanks for bringing that up. It's really hard sometimes on thin parts if you really want to see the details and mesh to 3D to be able to accurately capture it and mesh it to a good good element count through the thickness of the part with being able to reduce that aspect ratio. What I would recommend is take a look at the help file. It does list the recommendations for aspect ratios in there. If you're getting, we'll dive into it a little bit later in this presentation, but if you're getting really high aspect ratio and you really want to try and get that internal mesh to look okay to analyze, what you might actually have to do is reduce the global edge length, or at least the edge length in the region that is really thin that you're trying to capture, because in those cases that'll reduce so again, the 3D internal mesh is looking at that surface mesh to kind of keep an eye on it to be able to match it underneath as well. So whenever you're reducing the edge length on the surface, it'll kind of and reduce that element size a little bit more. Does that kind of answer it there?
Yes, thanks so much, Kristen. One other question as well at this time. So are there any advantages between using Inventor versus SimStudio tools that you know of?
So for CAD program versus SimStudio tools, CAD programs, even Inventor included in it, even though it's an Autodesk product too, it's really geared towards modeling that part and not necessarily troubleshooting. You can certainly use it as troubleshooting if you'd prefer that over if you're more familiar with Inventor versus SimStudio tools. SimStudio tools was used as if those of you who are listening, if some of you aren't aware, it's basically a package item where if you have the 2016 version of Moldflow, it was kind of piggybacked onto that installation, so it's a free installation along with it. And it uses Moldflow's license to be able to launch, so if you haven't checked it out, feel free to open it up, play around with it a little bit. We'll also demo it a little bit today. But again, the SimStudio tools is more geared towards you already have that CAD geometry created, and all you want to do is either change small things within it or maybe simplify the part, remove some features, that sort of thing. And again, it's very simplistic CAD program versus the powerful aspect of being able to really dive into designing things within Inventor.
Great. Thank you so much, Kristen.
Sure, no problem. Great questions coming in. Thank you all for shooting those out there for us. And feel free, keep asking. We've got people behind the scenes as well answering questions too. So, all right, moving on here. Now, I did mention that we do recommend a visual inspection whenever you're first importing that part and meshing it. It's kind of like a pixelated version. So up on top, you can see you can kind of see the image in the pixelated version, but you really see it when it's more defined. And that's the same thing when it carries over to the mesh that Moldflow applies. And it's the same with Advisor as well. If you're seeing kind of square boxy features instead of rounded features, that's typically a telltale sign that maybe you should try increasing that mesh resolution to be able to capture that geometry. And another thing to check whenever you are looking into an analysis fail due to meshing issues or geometry issues is the mesh statistics. So it's great to, we actually recommend to look at it before the analysis, but for those few that weren't looking at it before the analysis but they noticed their analysis fails due to one of those error messages, then looking at this mesh statistics after the fact can also help to determine what could be wrong here. And you can see I just ran a sample part here, and you can see the printout of the output of that mesh statistics here. And again, all these can be found in the help documentation on recommendations on aspect ratio, edge details, and so forth. But today I wanted to go through a few of these and actually demo on how to troubleshoot these, as well as go into a little bit more detail on that aspect ratio, since there is so much concern behind that. All right, so you hear aspect ratio. What does that actually mean? So if you look at that blue triangle shown on the screen there, basically it's the ratio of that A side to the B side, so the height to the width of it. And once that starts to get longer and longer, you're losing accuracy, because what the solvers are actually doing is looking at those red dots, the nodes there, and using those as triggers for that calculation. So it's taking basically the calculation for, say, flow at that first node, and then the second node, and generating a estimation for the center in there. So if you look at your results and you're seeing a lot of jumping around with that result, then you might want to consider decreasing that aspect ratio just to be able to get a closer history for what's actually happening with that flow. And you can see there, these I just pulled from the help documentation as well, the recommendations for aspect ratios within Moldflow. So typically the default is you want to try and get everything from midplane and dual domain under 20 to 1, but when you go to 3D, you want to get it to about 100, because 3D has a little bit more give because you're actually capturing the geometry. And then once you go to dual domain or surface mesh prior to meshing to 3D, you want to aim for about 50 because that'll even out to be around 100 whenever you do go and mesh to 3D. And again, when you're running certain types of analyses, such as cool and warp, you might want those nodes to be a little bit closer together to see that history a little bit more better. So we recommend about 20 before meshing to 3D. That way it will give more history and data points for the solvers to be able to read. All right, and right now I was going to go into a demo portion just for a few minutes here. Before I do so, are there any additional questions on any of that content? Okay, looks like there aren't, so we'll go ahead and switch out of the presentation here. There we go. All right, so okay, so right now I pulled up a couple sample parts. Sorry about that, a little echo. Okay, I made a couple of sample parts here. This is one that our development team was working with, and then I created a second one here for us. And this part, basically, I just wanted to show you, again, the definition. So with this mesh, I meshed it as an 1/8 of an inch edge length. And you can see it's capturing the geometry. However, it is kind of clunky looking. It's choppy, whereas you're seeing really all those edges of the triangles in there. But then once you switch it over to a more refined mesh, so this is about 50 thousandths of an inch, you can really see that round circle. And again, if you're working a lot with circles, using the edge length feature can also help to, or I'm sorry, the chord length feature can also help to really capture that roundness in it. Okay, and the second part that I wanted to kind of focus in on this part was that text feature. So you can see here on the more refined mesh, we can see much less high aspect ratio looking triangles in here, which means visually it looks okay to run like this. Again, it would be best to go through the mesh statistics and everything. If we do run through this, it might take a second here to generate. But you can see here, just looking at the general overview of them, maximum aspect ratio is about 19, so that's under the 20. And then looking at free edges, none. Non-manifold edges, none. Orientation looks good. Intersections and overlaps look good. And then even the match percentage, since this is dual domain, looks okay in here because it's above 85%. So again, if you're looking for recommendations, if you're not quite sure exactly what numbers to look for in these, take a look at that help file because it's definitely very helpful. I even look at it every once in a while just to make sure I'm looking at the correct percentages and so forth. Because one thing to keep in mind is this is for running dual domain, but if, say, we were running a 3D analysis, then this isn't too important to us. If we're running a dual domain analysis, this won't even show up because there's no second layer for it to match up to. It's just that center line of the part. Okay. And again, if we switched back to the 1/8 of an inch edge length and just focus in on that text, we can see it's a lot more choppy, very, very hard lines, very triangular features to it. So again, is that even worth it? Is it something to really affect the flow in that region? I would almost say just completely remove it because the flow is coming down. It's going to fill out this region. It's not the last place to fill, depending on where you're putting that gate. and just use kind of best judgment to determine if you should remove those or not. And same thing with those fillets and so forth. Here we've got some fillets. They don't look like they'd be too alarming for aspect ratio, but you might come into situations where you're using a much larger mesh, so it's really stretching that element out, and that would be a real pain to really go in and manually fix all of these. So it might be better to eliminate those fillets altogether because they're really not adding too much to the flow calculation. And again, this is the second part I modeled. Used that same 1/8 of an inch edge length. And you can see here, it looks good. It's still capturing geometry in here. It's looking a little bit strange around like rounded sections and so forth. Again, because I did not use any chord angle on here. But if we reduce that element size to the default, then you can really see that it looks good on there. Now, would you analyze this right away? You could. Might come up with an error message though, because if you do a quick visual inspection, you can see here, I'll zoom in on it for you, there's something strange happening with the mesh. Now, I made it a different color just to make it a little bit easier to see here. And even if we go to the other side here, looks like we're actually missing elements here. So if I were to get a technical support case in on, say, this part, I'd be curious on what exactly is happening on the CAD geometry in these areas, because there could be something happening on that that might be easier to fix in the CAD program rather than manually fixing them through the mesh here for the mesh repair tools. So at that, let me switch over to SimStudio Tools. And so what I actually did was modeled this program within SimStudio Tools. You can see here, there's tons of different tools you're able to actually create simple geometries, and you can even work with surfaces on here and then patch them all together to create solid bodies. You can use modification tools such as adding draft, shelling out parts if you want to combine different parts to it, and so forth. And if we look at this part, you can see here there's something strange right here. It's a different color. Usually when you import a part and it's all one body, it all looks the same. So here, because it's two different colors, or it's a different color from the part here, it means something else was happening here whenever you were modeling it. So what we can also do is, actually, let's do that. If we look through it, now this is something that I just added after the fact. It doesn't necessarily represent the mesh issues that we were seeing here, but it's something similar that could happen whenever you're troubleshooting those types of mesh issues. You might see maybe it's a surface body instead of a solid body, and the face is extending further into, say, this section than meeting up and connecting it. What you can actually do is use the inspect option here and do a section analysis. And if you saw our webinar on SimStudio Tools maybe about a year back now, James actually went through and showed this to greater display and described that when you're working with a surface body, this will actually show as hollow instead of filled in like this. And it's a neat way to, one, be able to tell if it's solid, and two, be able to tell if your part's complete and if the thicknesses match up. So here, this one's it's a little bit funky, basically going into different thicknesses, but we're not worried about the part design right now. We're just worried about looking at the CAD geometry itself. So let me go ahead and switch this off. Oh, cancel. There we go. And now back to this part here. Again, since it's a different color, it kind of raises alarms for me. So looking at it like that, something's up. If we go to the sketches here, extend that, you can see there's a sketch here. If we turn that off, it turns back to the normal color. Turn it on. So there's an extra sketch here that wasn't used, so it's changing the color. Now, what that'll actually do is, it won't really do too much to the mesh here just because this is a straight line, but if you have random sketches throughout your part, it could throw off some meshing within it. So you can easily just click on it and click delete on your keyboard, and that resets it. Or what you can also do is right-click it over in the tree here and just click delete, and you can see it switches it back to the same color as the rest of the part. All right, so switching back to Moldflow here, we have these issues. Say we didn't see anything within the CAD body or CAD geometry that was triggering it. So let's take a look at it. If we use the mesh diagnostic tools, we can actually use that to help find these types of issues if it's not real visible for us to see. So utilize these when you're troubleshooting your model. If we go to the overlap one, I don't think this one will show it because this one's a little bit strange in that it's looking at, it's almost a lip in there, a gap between these two elements. So it's not necessarily overlapping or intersecting, it's just kind of overhanging on it. So for that one, there's not too much we can do with the diagnostic tools, but if we look at this overlap over here, we can certainly see lines crossing against one another, and that's showing intersections. So if we actually did the overlapping element diagnostic here, it'll highlight those all as overlaps and intersections depending on if it's an overlap or intersection there. And in this case, because they are elements going on top of one another, it's basically just marked as overlaps. So sometimes it's a little hard to work with this diagnostic on. What I like to do is just toggle this on and off to make it a little bit easier to see there for us. So the other thing, let's turn on nodes. And it looks like there's clear overlap there that's really causing some issues. So typically what I like to do, I just click delete, and that looks like it basically resolved that there. But we still see this line going across here. Now, it doesn't look like it's too bad, but you can see here that this isn't a triangle. So it's not a true element. The element is actually going up here. So this one is overlapping those ones there. To resolve that, what I would probably do is, again, I might just delete one of these. And for these, do it the way you know. You can do this. You can delete elements and then fill it in with a hole. Or you can go through and move or merge nodes together to resolve them. Sometimes I've found sometimes just deleting them like this is a lot easier in some cases. And then from there you can use the fill hole feature that was moved to this advanced option menu. Select by triangles or select by nodes. Let's try nodes. And you can see when we're doing this, it's actually filling out, oops. You do have to select the control button while you're selecting these, but you can see it's actually filling out where it would be filling in that hole. So if I just stop there, it would fill in that section and leave this empty. But if we keep going, get all those nodes that surround it. And you can also use the search button, which automatically searches around that node that you select. Click apply, and there we go. Ready to go. Now, after you do that, one thing you really want to make sure you do is whenever you fill a mold like that, or fill a hole, you want to check the orientation. So if we go through the orientation diagnostic, we can see here that it's oriented the wrong way. So that can really become an issue whenever you're going to run that analysis with dual domain mesh, because it's not able to find a match to it because it's oriented as the bottom facing up. And for dual domain, you want it to show blue on top here because it's going to match to the inside. So if we delete one of these here, you can see the inside is all red. Just undo that. Now to fix this, you can either do it manually, do orient elements, and you can either do a search for it or just manually select them like so, and either flip the orientation or align orientation. Align basically looks at the surrounding elements, so if you have a single element that's unoriented, use that align and it'll orient it to all the surrounding. Flip orientation does the same, exactly what it's saying, basically just reverses it from where it is now to the reverse of it. So instead of bottom, it'll show up as top. So if we click apply, that's blue, and close out of that. So that's one way to do it. And again, you can toggle it on and off. For this diagnostic, it's almost easier to keep it on just to be able to identify which elements are unoriented. But you can also use this orient all, which typically is able to capture them. Sometimes it's not able to. So in this case, you would have to just go in and manually orient it. So flip, apply. Oops. And in that case, that means something else is going on. So let's delete that one real quick. So it looks like there is actually an overlap on there. And again, you'll find these different mesh things or mesh issues whenever you're going to troubleshoot them like this. So in this case, if we go through and orient again, there we go. So all I did there was just delete the one that was on top of it. And for the second one there, I just oriented it to match the others. And you can see here, down here is a hole that we can work with. Since we already worked on that, I'll let that go right now. And it looks like we're getting pretty close to the end of the webinar. So what I'll do is I'll stop here and see if we have any questions, anything else that users would like to see, maybe fix up this or anything like that. So Beth, any questions out there?
Yeah, we have a couple questions coming in. We also, as Kristen mentioned, have some other technical support behind the scenes helping to answer, but we can go through a few of them. So basically this one is there any recommendation, I'm sorry, I think we got that question. Okay, so for a dual domain mesh, if the addition of chord angle length, so for example, 45 degrees, 65 degrees, etc., does not result in improved reciprocal match ratio, is there any advantage to using the chord and meshing beyond making the part look nicer?
So again, it's all about trying to capture the geometry. That's a great question. You really want to try and capture the geometry of the part. If you're noticing that it's not matching up exactly to the curve, then basically that could introduce either additional or lesser volume of material that you need to fill the part. Granted, it's not going to be significant unless you have a lot of round features on it, but it's again just something to keep into consideration whenever you're looking at it. And again, if you're really not happy with that, then you can also go to 3D mesh. So if you're working with thick, chunky, or a lot of round features on your part, then sometimes 3D mesh might be able to better capture it just because you're really seeing that internal mesh. One thing I didn't really mention too much is, so for this part here, it's a dual domain mesh. If we go to this diagnostic, the mesh match option here, and click show, basically what this does is show you exactly what's matching on your part. And from there, you can actually decide, for this part, the majority of it is being captured. If, say, you really want to see what's going on in this section, then you might want to consider either refining that mesh or trying to convert it to a 3D mesh to be able to really capture that thickness. Because if we switch back, I guess I could look at the mesh here, but whenever you mesh to 3D, you actually see that calculating model thickness line in here. And again, for dual domain mesh, it's really looking for that mesh match to be able to recognize the thickness of your part and capture that geometry correctly. If you're, say, getting this unmatched element count all throughout your part, then it's really not representing your CAD geometry as well as it can, or as well as it should be. So that's another thing to keep in mind. That's why I recommend really going through these diagnostics even before you run the analysis. Again, the thickness diagnostic can help too, basically showing you exactly what thickness it's capturing. So here we're seeing a measurement for that thickness, but since it wasn't matching with an element on the other side, it's going to be tough. It's really looking at the elements around it to help determine what thickness that is. And that's where error can be introduced in when you're looking at your results. There could be some weird things happening in there.
Thank you. Another question we have is there a recommended maximum average aspect ratio for 3D tetra elements for models to be used in a warpage analysis? So for example, below 5 or below 4. We also had one of our support specialists answer this question, but I wanted to see if there was anything you wanted to add to it, Kristen. But basically, there is no specific guideline. However, if you follow the guidelines for surface to thickness, so surface edge length should be 2 times the thickness, then you should be good to go.
Yeah, I would agree with that answer. Basically, you want to keep to that recommendation if you're really not sure at what to put for it or what to try to aim towards. I don't know. Does anyone else have anything to add on the line here, or any of the other specialists on the line here?
No, I'm the one that answered it. This is
Oh, hi, Jay.
Thank you. No, yeah. So you know, for every specific case, you could have a you know, a slight modification of it. One of the things to keep in mind is you know, the use of local mesh densities to, you know, you have one area that the thickness is a lot different than something else, and you want to capture what's going on there. Maybe using a local mesh density for a given area will, you know, get the proper refinement in that area without creating a whole lot of elements overall that you don't necessarily need, and things like that. But definitely with the 2016 and even more specifically with the 2017 meshers, if you get reasonable edge length inputs, and you have a good watertight CAD model, it's going to mesh pretty well for you, and you shouldn't have too much cleanup necessary.
Thanks, Jay. That's a good point with the local mesh density. For those of you who aren't familiar with it, for the 2017 version, we did change it up a bit, but you can access it the same way you did before. So say we wanted to add that local mesh to, I don't know, this inside fillet here. If you right-click it after selecting it on the CAD geometry, and again, this would be prior to meshing the model, click on this define mesh density, or you can go up here to the density button under the mesh tab and click it that way as well. And here it's basically showing all the faces in your CAD body. So basically, if we're just trying to focus on that single edge, just click Add because you already had it selected. And down here, you can either apply the global mesh settings to it. So basically, whenever you go to hit this Generate Mesh button and then define the global edge length there, then it would apply that setting to it. But say you want that a little bit more refined, you can go in here and change it to a lower value, or if you're working the reverse, if you want to change it to a higher value, you can enter in whatever you want here and then click apply and OK. And then whenever you go through and actually mesh the model, it'll refine the mesh towards that section and lead into it from the mesh around it. So there's a little gradual size increase in there, so you're not just going from super big mesh to super small mesh in there. It's going to be a little bit of a gradual size difference there. All right, any additional questions we wanted to bring up?
Yeah, I think just we have a user who, again, wants to know where he can download the slides and where this video will be posted, but I think we'll touch on that again here shortly in just a minute.
Perfect timing. All right, thank you. And I do see the time is 12:01, so I apologize for going a little bit over today, but hopefully we were able to answer a lot of your questions. Again, in summary, basically we talked about the mesh, how important it is to get a good simulation out of your Moldflow analysis. And Moldflow has those tools built into the analysis, or built into the Synergy or user interface there, basically for you to help to diagnose and fix those errors. And as well as we discussed the SimStudio tools and your CAD programs help to better resolve those issues if they're larger than one or two little fixes. And again, keep in mind, it takes practice to recognize these and to really troubleshoot them. So play around with it yourself, see if you run into any questions. If you do, what we have is the forums. We do monitor these, the support team, and even other users. It's great to get other feedback from maybe someone who's a little bit more experienced. So go to the forums. If you're part of or on subscription, come to us with help. Search through the Autodesk Knowledge Network. And again, there's a link to how to submit support cases if you are on subscription. And then the link down below there, the autodesk.box.com/moldflow18, that's where you can download the PDF file of this slide deck, as well as the sample file that we worked on today. And another thing to note is within that box file, within that public document there, I did include some additional slides within it that go through how to troubleshoot specific things within the mesh statistics. So take a look through it, see if there's anything in there that can help you. Again, this is a starting point for how to troubleshoot errors and issues with your model. And thank you all for joining. I hope we were able to teach you something new today. And thank you all again for joining. Have a great rest of your days.